So let's talk about the absolute nightmare scenario for anyone directing a live broadcast.
I know this one.
You're covering a huge live event, maybe a marathon or a golf tournament. Your camera is miles away from the production truck, and the feed just dies.
Complete signal loss. Or, and this might be worse, you get that awful digital jitter where the picture just tears itself apart.
Exactly. We really take clean live video for granted, but moving that amount of uncompressed data across a city in real time is a massive physics problem.
It truly is.
And that's why today we're looking at a piece of hardware designed to solve exactly that. It's the Thor Broadcast F-8SDI-3G-GET-TxRx-RM.
That is quite a name. I think it wins the award for the least catchy product name we've ever discussed.
It's a mouthful for sure, but what it does is deadly serious. This is a commercial-grade fiber optic transmitter and receiver kit.
Okay.
And our mission for this deep dive is to unpack how the single box manages to, well, shove 8 separate video channels and high-speed internet down one tiny strand of glass for over 20 miles.
And shove is the right word. We aren't talking about your typical compressed internet stream here. This thing handles serial digital signals.
So SD, HD, 3G-SDI, that kind of thing.
All of it. We're talking uncompressed, raw feeds straight from broadcast cameras.
Wow.
It's pushing up to 3.0 gigabits per second per channel.
Per channel. And if you tried to do that with a standard copper coax cable, you'd be lucky to get, what, a few hundred feet?
300 feet maybe before it just dissolves into noise. Physics simply isn't on your side with copper at that kind of bandwidth.
Right. But this Thor unit, it uses single-mode fiber. The spec sheet says the standard platform can hit 40 kilometers.
Which is about 25 miles. And there were even options to go further, up to 50 kilometers if you use specific high-quality DFB lasers.
And that's the real-world difference between parking your production truck outside the stadium versus parking it in the next town over.
Absolutely.
Now, I want to drill down on the GET part of that messy model name. That stands for Gigabit Ethernet.
Yeah, and this is the +1 feature that I think engineers really get excited about. It's not just an 8-lane highway for video.
There's a dedicated lane for data.
Exactly, which creates a bidirectional link, so you're not just seeing what the camera sees.
You can control the equipment, transfer files, or even give the operator an internet connection.
All on the same single fiber that's already carrying 8 channels of video. It's incredible.
Okay, so the real question is how? How do all those signals not just crash into each other? 8 huge video streams and a data stream on one cable seems impossible.
That is the engineering trick, isn't it? It all comes down to a technology called CWDM.
Coarse wavelength division multiplexing.
It's a mouthful, but the concept is really quite elegant. You need to think of the fiber cable not as a single pipe, but as a whole spectrum of light.
Okay.
The device takes those electrical video signals and converts them into light, but, and here's the key, it assigns each channel a slightly different color or wavelength.
So it's like a prism in reverse. It merges all these different colors of light into one beam for the journey.
Precisely. And then the receiver at the other end has another little prism that splits them all back out to their respective ports.
And the docs say it uses industry standard modules, so it's not a closed system.
Right. They explicitly mention it's compatible with third-party gear like the Python series. You can mix and match.
That's pretty rare for high-end proprietary tech. So speaking of that, how hard is it to set up? I mean, fiber optic multiplexer sounds like a miserable afternoon with a user manual.
You'd think so, wouldn't you? But the documentation says it's plug and play. No configuration, no software.
For real?
It just auto-detects the input signal. Standard def, 1080p, whatever. It just figures it out and makes the adjustments on its own.
Which is absolutely crucial for electronic news gathering. If you're setting up for a breaking news event, you don't have time to be configuring IP addresses.
Not a second. And reliability is the other half of that coin. We mentioned jitter earlier. Over 25 miles, even a light signal's timing can get a little degraded.
Okay, so how does it fix that?
The receiver unit has something called reclocking built right in.
Which is kind of a reset button for the signal's timing.
That's a perfect way to put it. It strips the signal down, perfectly realigns the digital pulses, and then sends it out completely fresh.
So the video that leaves the receiver is basically identical to what entered the transmitter 25 miles away.
It should be mathematically identical, yes.
Yeah.
The whole thing is built to just sit in a rack and work.
It's 1RU, rack-mountable, designed for 24/7 operation. It's just utility-grade infrastructure.
Exactly. It's invisible tech. Whether it's for scientific research or live sports, If this box is doing its job, you never even think about it.
That's such a good point. We all obsess over the cameras and the screens, but the real magic is so often in the transport, the plumbing in between.
Mm-hmm.
So here's a final thought for you. The next time you're watching a flawless live game, just consider that picture is probably riding a laser beam through a strand of glass, being split and reclocked in milliseconds across an entire city.
And doing it 8 times over on just a single cable.
Thanks for listening to this deep dive into the backbone of broadcast.
We'll catch you on the next one.